This is Pre-Cal Lecture 7.5, which is an introduction to matrices. 7.5.1. You might have had a little bit of this last year in Algebra 2. But a system of equations can be expressed as a matrix. Okay, so let's go ahead and write a couple of equations down. Let's say we have 2x minus 3y is equal to 1. And then 4x plus 7y is equal to 5. Okay, we can express that as a matrix. Okay, so you just take the coefficient. So in this case we'd have 2, negative 3, and 1, and 4, 7, and 5 for the second equation. Now some people like to then put a dash line there, all right, to show that that final column, the third column, doesn't have any variables in it, it's just a constant. Okay, but you don't have to put the dash line. Right, so we would call this a 2 by 3 matrix. Okay, so matrices are expressed in rows times columns. Rows would be horizontal, columns are vertical. If we were to have a matrix like this, where we just have 1, 3, negative 1. So it has 3 rows and 1 column. So we would just call that a 3 by 1 matrix. I'm going to give you just a second to finish writing that down. Our first example is represent the following system with a matrix. Alright, so let's say we have 2x plus y is equal to negative 1. And then just x is equal to 3, no y term. Alright, we would represent that with our first row is a 2, a 1 for the y, and a negative 1 for the constant. And then the coefficient in front of x is 1. There's no y value, so we put a 0 there. And the constant is 3. So that's how you deal with when no variable exists in a particular system. All right, so again, if you like putting the little dash line, go ahead and put it. If not, no problem. All right, section 7.5.2 is the arithmetic of matrices. Okay, so the little bit of instruction here to add and subtract matrices. they must have the same number of columns and rows. All right, so for example, let's say we had a matrix 1, 2, -1, and 0, 3, 5. We want to add matrix 1, 3, 2, and 1, 4, 0. All right, so this is a really simple process. You're just going to add each digit in the corresponding section of each matrix. So row 1, column 1 here is 1. Row 1, column 1 here is 1. 1 plus 1 is 2. So it's just going to be 2. 3 plus 2 is 5. -1 plus 2 is 1. And then the same for the second row. 0 plus 1 is 1. 3 plus 4 is 7. 5 plus 0 is 5. Right, so that would be the solution matrix for the addition of those two equal matrices. I'll give you just a second and we'll do another one. Okay, this time I'm going to fill in these two matrices, and instead of adding, we're going to subtract. And it's just like you think it would be. Let's say we have 1, 2, -1. I didn't really need to erase those two. And 0, 3, 5. And we have 1, 3, 2, and 1, 4, 0. And you do the same thing. Instead of adding, we just subtract. So 1 minus 1 is 0. 2 minus 3 is -1. -1 minus 2 is -3. 0 minus 1 is -1. 3 minus 4 is -1. 5 minus 0 is 5. Okay, so very simple process, adding and subtracting matrices. Right. All right, multiplying matrices can be a little more complicated, but not this first section. Multiplying matrices by a scalar. Okay, so our first example is multiply three times the matrix 1, 2, 3, 4. All right, so that's going to be, you multiply 3 by each of the 4 digits. So that'd be 3, 6, 9, and 12. Okay, then we can add another operation. So let's take -2 times the matrix 5, 4, -1, -1, and then add to that 4 times -9, 4, -2, -1. All right, so I'm just going to do the operation and bring the matrix down. So that's going to be -2 times 5 is -10. Negative 2 times 4 is negative 8. Negative 2 times negative 1 is 2. And then also 2 for that, for the last one. And we would have 4 times negative 9 is negative 36. 4 times 4 is 16. 4 times negative 2 is negative 8. 4 times negative 1 is negative 4. And then we're going to add each corresponding matrix value. So negative 10 plus negative 36 is negative 46. Negative 8 plus 16 is 8. 2 plus negative 8 is negative 6. 2 plus negative 4 is negative 2. All right, I'll give you a chance to pause the video and enter anything that I was blocking your view on. Okay, and the last section for 7.5 is multiplying matrices. And the rule on being able to multiply matrices is not the same as the rule for adding and subtracting. So in order to multiply two matrices, the number of columns in the left matrix must equal the number of rows in the right matrix. Okay, the number of columns in the left matrix must equal the number of rows in the right matrix. So our example is we want to multiply one, 3, 2, 1, 4, 0. We want to multiply by this large matrix. 1, I'm going to go vertical this time. 3, negative 1. 1, 0, 1. 2, 0, 5. Negative 1, 4, 1. Okay, so your final matrix will give you the number of rows, which is 2, from your first matrix, and the number of columns from the right matrix. Okay, number of rows on the left, number of columns from the right matrix. So I'm going to go ahead and write in a solution matrix. So it's going to be 2 rows times 4 columns. Okay, so we have to take this one digit at a time. So what you do is you take the first row with the first matrix, multiply it by the first column in the second matrix. So row horizontal times vertical. And I like to write it out like this. So for row 1, column 1, I have, if I take this and multiply it by that, I've got 1 times 1 plus 3 times 3 plus 2 times negative 1. So that's 1 plus 9, which is 10, minus 2, which is 8. So our first digit in the solution matrix is 8. Now we're going to do row 1 times column 2. That's going to be 1 times 1 plus 3 times 0 plus 2 times 1. 1 plus 0 plus 2 is 3. All right, so we're going to put a 3 there. Now row 1, column 3. So we're going to do row 1 times column 3. So that's 1 times 2 plus 3 times 0 plus 2 times 5. It's 2 plus 0 plus 10, which is 12. And then finally, for the top row, row 1 times column 4. So that'll be 1 times negative 1 plus 3 times 4 plus 2 times 1. So negative 1 plus 12, that's 11, plus 2, which is 13. All right, so we're half done. All right, again, row 1 times each column. Now we got to do row 2. So we've got row 2 times column 1. Second row, first column. 1 times 1 plus 4 times 3 plus 0 times negative 1. So that's going to be 1 plus 12, which is 13, plus 0. That's 13. All right, row 2, column 2. 1 times 1 plus 4 times 0 plus 0 times 1. So that's going to be 1 plus 0 plus 0, 1. Fill that in. Row 2, column 3. 1 times 2 plus 4 times 0. We love those zeros. Plus 0 times 5. All right, that's just going to be 2. And then our last digit, row 2, column 4. 1 times negative 1 plus 4 times 4 plus 0 times 1. That's going to be negative 1 plus 16, which is 15. All right, so there's our solution matrix. You just got to be a little careful, go slow. Remember, it's row times column. Chart it out like this, that'll help not make a mistake. I believe you can check these in your calculator if you want to figure out how to do it in your calculator, but on the homework, you've got to show the work, and also on the test, you'll have to show the work. So give you a second to pause the video and write down anything that you've missed, and I'll do one more example of multiplying matrices. All right, our last example is a much smaller situation. So let's say we have 8, 5, 2, 7, 4, 1, 3 rows, 2 columns. We're going to multiply that by 5, negative 1. So 2 rows, one column. Okay, so that does meet the criteria. The number of columns in the left matrix, which is 2, equals the number of rows in the right matrix. We have 2 columns, we have 2 rows. All right, so row 1 times column 1. So we're taking that row times that column. So we've got 8 times 5 plus 5 times -1. That's going to be 40 minus 5, which is 35. So our solution matrix is going to end up being 3 rows and 1 column. So go ahead and do a skinny matrix there. So 35. All right, so we've got row 2 times column 1. So we're going to take the 2, 7 row times the single column we have. So that's 2 times 5 plus 7 times -1. 10 minus 7 is 3. And then row 3, column 1, we've got 4 times 5 plus 1 times -1. 20 minus 1 is 19. So our solution matrix is 35, 3, and 19. All right, I'll give you a second to pause and write that down if I was in the way, and then I will give you the homework solutions to 7.5. Okay, it almost take me longer to write these down than to work some of them. Number 1, we'll have 2, 1, 0, 4, 7, -1, -3, -2. Number 2, we have 0, 2, 1, 0. 5, -1, -2, 3. You should definitely do these on your own before you look at the solutions. All right, number 3, we'll have 0, -7, -9, 7, -7, 1, -5, -15, -1. All right, number 4. -7, -2, -10, 13, 10, and 8. Number 5, -10, 50, -11, -12. Number 6, we'd have 6, 21, -30, -36. Right, number 7, skinny little 1-row matrix. 2, -5, 0. Okay, remember, please show your work so I can give you credit. Number 8 is a 3x3, -2, 0, 3. -2, -6, 9. And -12, 15, 3. And finally, number 9 is a 2x2. -3, 2, -5, -26. Okay, I'll give you a chance to pause the video, write those down. You should be capable of doing all 9 of those now. Just make sure you bring them back to school when school reconvenes, and I'll work any that you need me to work. So now you should be able to do what we've covered so far: 7.2, 7.3, 7.4, and 7.5. I'll get you 3 more lectures in the coming days.